Hi and welcome to this 12th video on group theory. We will see a problem on cyclic groups in this video. Now the problem is whether your Z phi with respect to addition modulo phi is going to be a cyclic group. Okay, so what do we mean by Z phi is the integer modulo phi. Modulo phi is you add any element, divide by phi, and the remainder which you get positively will be called as your class addition class modulos. So when you divide any element on addition with phi, the possible remainders will be 0, 1, 2, 3 and 4. Only these elements will be there. When your remainder becomes 5, it goes in 5 one more time, leaving you with remainder as 0. So this has to be shown as cyclic group. What do we mean by cyclic group? Cyclic group is one element. So there is going to be an element called as A that belong to your set G, such that this A rise to the power of any integers m will generate the entire set of G. So your G will be generated by this one single element called as A when it is done the binary operation of m number of times. So if there exists such an element, then the element will be called as generator and the group will be called as cyclic group. Now this is going to be addition modulo, and we know that it is going to be finite in nature. So finite sets can be just shown to be a group using your Cayley's table. So let me go with Cayley's table 2, 3 and 4. Okay, now the addition is performed as 0 plus 0 is 0, 0 plus 1 is going to be 1, 0 plus 2 is going to be 2, 0 plus 3 is 3, 0 plus 4 is going to be 4. 1 plus 0 is going to be 1, 1 plus 1 is going to be 2, 2 plus 1 plus 2 is 3, 1 plus 3 is going to be 4, and now comes 1 plus 4 is going to be 5. 5 on divided by 5 leaves you a remainder 0, so this will be 0. 2 plus 0 is going to be 2, 2 plus 1 is 3, 2 plus 2 is going to be 4, 2 plus 3 is 5, 5 on remainder will give me 0. 2 plus 4 is 6, 6 on division with 5 leaves me a remainder 1. So this will be 1. 3 plus 0, 3, 3 plus 1 is 4, 3 plus 2 is 5, so 0, 3 plus 3 is 6, so remainder is 1. 3 plus 4 is going to be 7, 7 on division by 5 leaves you a remainder 2. Now 4 plus 0 is going to be 4, 4 plus 1 is going to be 5, so remainder will be 0. 4 plus 2 is 6, so remainder is 1. 4 plus 3 is going to be 7, remainder 2. 4 plus 4 is 8, so remainder is going to be 8 on 5, remainder is going to be 3. So this is my table for showing that it is going to be a group. What I need to show is going to be, you have to have closure to be true, you need to have associative law to be true, you need to show that identity element exists and inverse element exists. Now about the closure, I see that this element or this table is filled with only these 5 elements 0, 1, 2, 3 and 4 and not with any other element, in which case it is going to be closed. What do we mean by associative law? Associative law is such that you have A plus B plus C. So this addition combination is the same as A plus B brackets plus C. So everywhere it is addition modulo over here. So let me take the combination of 2, 3 and a 4. Okay, now 2 plus 5 plus 4. Okay, now what is going to be 3 plus 4? 3 and 4 now gives me 2. When I do 2 with addition modulo 2, so 2 with addition modulo 2 is going to be 4. So answer is going to be 4 for my left hand side. Let me check with the right hand side. What is going to be my right hand side? Right hand side is evaluation of these brackets first. 2 plus 3 with addition modulo. What is going to be 2 and 3 addition modulo? This is going to be equal to 0. And with that I will add the last number called as 4. So 0 plus 4 will be equal to 0 and 4 is going to be 4. Okay, so I now have 4 on my left hand side as well as a 4 on my right hand side, which says that associative law is going to be true. So associative law has been shown to be true. What is the next thing is going to be identity element. What is the identity element? You take the element and you get back the same element, then you call it as identity. You take 0, you get 0. When you get it, you get it on 0. Okay, you take 1, you get the same 1 when you get it on addition with 0. You take 2, you get the same 2 when you get it on adding with 0. You take 3, you get the same 3 when you get it on adding with 0. You take 4, you get the same 4. How do you get it? On adding with 0. So what is going to be the identity element? The 0 is going to act as your identity element. 0 is going to act as my identity element. Now how about the inverse? Every element will have a different inverse. So what is going to be inverse? On operation with what, you will be getting your 0 back. Element with what will give you 0 back? 0 plus 0 gives you 0 back. 1 with what will give you 0? 1 with 4 will give you 0. So what is the inverse of 1? Inverse of the element 1 is going to be 4. Now 2 with what will give you 0? 2 with my 3 will give me 0. So inverse of 2 will be the element called as 3. Now 3 with what will give me 0? 3 with the element 2 will give me 0. So the inverse of the element 3 is going to be 2. Now 4 with what will give me 0? 4 with 1 will give me 0. So the inverse of the element 4 is going to be equal to 1. So all the elements, 0 has inverse, 1 has 4 as inverse, 2 has 3 as inverse, 3 has 2 as inverse, 4 as 1 as inverse. So all the elements have inverse. Therefore you show that it is going to be satisfying the inverse law, identity law, associative law and closure law. Therefore this becomes a group. Now the extra condition over here is cyclic group. What do we mean by cyclic group? Cyclic means one element must generate the entire set G. Okay, what is your G now comprising of? G comprises 0 class, 1 class, 2 class, 3 class and 4 class. So now what will generate this? With the binary operation addition modulo 5. Okay, so I need addition modulo 5 and this has to be generated. Now take the element 1. 1 with single copy of 1 will have the element 1 to be generated. What will be 1? Addition modulo of 1. 1 plus 1 will give me the group 2. Now 1 addition modulo of 1, addition modulo of 1. What will this now generate me? This will generate me the class 3. 1 addition modulo of 1, addition modulo of 1, addition modulo of 1. What will this generate me? This will generate me class 4. Now when I take 5 copies of 1, addition modulo 1, addition modulo 1, addition modulo 1, 4 and this is my 5th copy. So when I take 5 copies, what will happen? 5 divided by 5, 0 will get generated. So I have generated 1, I have generated 2, I have generated 3 and I have generated 4 and the last element 0 also, using one single element. One element must generate the entire. So which is that element? This element 1 is going to be called as the generator of my group Z5 with respect to the addition operation plus 5. Now there is also a property says if A is a generator, then your A inverse is also a generator of the group G. Okay, now I have seen that 1 is going to be a generator. What is going to be the inverse of 1? Inverse of 1 is 4. So let me check if 4 is going to be a generator. Okay, what is class 4? It is 4. What is going to be 4? Addition modulo 5 of 4. 4 plus 4 is going to be 8. 8 on division with 5 gives me remainder 3. So 4 addition modulo 4 with addition modulo 4. So 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 on division with 5. So this gives me remainder to be equal to 10, 11, 12. So remainder will be 2 for me when you divide it by 5. Now let me take 4 copies of 4. So 1, 2, 3, 4. 4, this is going to be 8, this is going to be 12, and this is going to be 16. What will be 16 divided by 5? This will be leaving me a remainder called as 1. And now when I take 5 copies of 4, so what will happen? Second copy, third, fourth, and fifth copy. Now when I take 5 copies of 4, I will have 20, and 20 divided by 5 will leave me a remainder of 0. Now I see that 4 also generates the element 0, 1, 2, 3 and 4. So in which case what we say? The element of class 4 is also a generator of the addition modulo 5 class. So whenever A is a generator, its inverse will also be a generator. So this class 4 will also be a generator. Therefore this Z5 with respect to addition modulo 5 is going to be a cyclic group, and hence the proof. Happy learning, keep learning.